This may be one of the most intricate astronomical mysteries in human history, the elusive planet that once existed between Mars and Jupiter. This seemingly outlandish question has puzzled astronomers for decades. But what is the story behind it? As early as 1766, the German astronomer Johann Titius accidentally discovered that the distances of planets from the Sun seemed to follow a very peculiar pattern. Taking the distance from the Sun to Mercury, which is 0.4 astronomical units, as a base, he noted that the distance from the Sun to Venus is 0.4 plus 0.3, the distance from the Sun to Earth is 0.4 plus 0.6, and subsequently, the distances to Mars, Jupiter, and Saturn are 0.4 plus 1.2 plus 4.8 plus 9.6. It seems that the positions of all planets are arranged in the sequence of 0.4 plus 0.3 multiplied by 2 raised to the power of n. However, Titius noticed a problem. If this pattern holds, there should logically be a planet after Mars, with a distance of 0.4 plus 2.4 astronomical units. So where is it? This statement shocked the entire astronomical community at the time, because it provided a mathematically and astronomically elegant explanation. Subsequently, Johann Bode summarized this into an empirical formula that could express the average distance of each planet from the Sun, known as the famous Titius-Bode law. This led people to fervently search for this theoretically vacant planet. However, after more than 1,000 years without significant discoveries, finding this new planet proved to be no easy task. But just a few years later, the discovery of a new planet sparked a major stir. In 1774, German musician William Herschel, indulging his passion for celestial observation, crafted a large metallic reflecting telescope with a 1.2-meter aperture and a 12-meter tube. Finally, one night 7 years later, he discovered the seventh planet of the solar system, Uranus. After calculations, astronomers made a surprising discovery. The average distance from Uranus to the Sun was 19.2 astronomical units, which closely matched the 19.6 units predicted by the Titius-Bode law. This discovery reinforced the belief that there must be an undiscovered planet between Mars and Jupiter. Yet, despite their efforts, astronomers could find no trace of it. It wasn't until the night of January 1, 1801, that Italian astronomer Giuseppe Piazzi, while observing the sky, spotted a dim star that appeared to be moving slowly. After weeks of observation, Piazzi concluded that this was not a comet. Further calculations showed that not only was its orbit elliptical around the Sun, but its orbital radius was approximately 2.77 astronomical units, which was very close to the 2.8 units predicted by the Titius-Bode law. Additionally, it was located right between Mars and Jupiter. Consequently, many believed this was the missing gap planet, naming it Ceres. At the same time, astronomer Olbers argued that, although Ceres was very close to Earth, its brightness did not resemble that of a typical planet. Shortly after, in 1802, Olbers discovered another celestial body, Pallas, in nearly the same orbit as Ceres. Over the following years, astronomers found similar bodies, such as Juno, Vesta, Hygeia, and Eros. It then became clear that the location of the so-called gap planet was not occupied by a single planet, but rather a multitude of smaller celestial bodies. Thus, the astronomical community collectively referred to these bodies as asteroids, and named the region where they reside the asteroid belt. With the continuous advancement of observational technology, humanity has now discovered over 120,000 asteroids in this region, yet a true planet has never been found. Therefore, the mystery of the missing planet, which had troubled humanity for nearly half a century, was finally resolved. The remarkable Titius-Bode law may simply be a fascinating mathematical coincidence after all.